So I solve for x and y. X would be x bar minus 26/25. Y is y bar plus 11/25. And now I can replace the x's and y's here. What about dx and dy? Well, that actually works out pretty easily, because if you take the differential of both these little equations, dx will be the same as dx bar, dy will be the same as dy bar. So now we're ready to substitute. And you know, with experience, if you're confident of solving your system, you can actually just write out the equation. But I'm going to verify this, so this will make it kind of tedious. But let's go ahead and just, for verification purposes, I'm going to plug in these substitutions. And it'll get a little messy here. I've got the bracket, 3 parentheses x bar minus 26/25 minus 2 parentheses y bar plus 11/25 plus 4 close bracket dx bar. Let me separate these here. And then we have this part, which I'll write on the second line here. So minus bracket 2 parentheses x bar minus 26/25 plus 7 parentheses y bar plus 11/25, and then minus 1 close bracket dy bar, and all that's equal to 0. Alright, well, here we go. So here I've got 3x bar minus 78/25 minus 2y bar minus 22/25 plus 4. And because I know I have fractions with a denominator of 25, let's go ahead and change 4 to 125. And this is dx bar minus, now this part, 2x bar minus 52/25 plus 7y bar plus 77/25, and then minus 1 would be 25/25, close bracket dy bar equal to 0. Alright, it's rather messy, and but look at this. Negative 78 minus 22 is minus 125 plus 125. Those cancel off. And then, let's see, negative 52 plus 77 is positive 25. 25 minus 25 is 0. So those constants cancel off. And here we go. We have changed the problem into this one without the 2 coefficients. So I'm going to erase this mess here. So I took this equation, rewrote it up here, and as I said, it came out to be this equation with x bars and y bars. Make sure I get my x bars and y bars in there, without the coefficients. So, you know, if you were confident of the substitution that these numbers are correct, then you could just immediately rewrite this equation without going to this trouble. Now, I never get tired of seeing this stuff work, so I don't mind doing that extra work, because to me it's kind of fun to see it work. Alright, well, let's erase this mess down here. Now we have a standard differential equation with homogeneous coefficients of order 1. And I'll solve it by the usual technique. So this is probably the boring part, because we've done this before. So I'm going to let u equal to y bar over x bar, which means that y bar is u x bar, and dy bar would be u x bar prime plus u prime x bar. Nope, I'm got a little careless here. It's not primes. We're using differentials here, not derivatives. Difference between differentials and derivatives. This will be u dx bar plus x bar du. There we go. So take the differential of both sides, not the derivative, and you get differentials. Alright, so we're going to substitute all this stuff into here. And that gives us 3x bar minus 2u x bar, parentheses dx bar, minus parentheses 2x bar plus 7u x bar. And then we have this mess. Dy bar is u dx bar plus x bar du. All that equals to 0. And if you look carefully here, we could factor out an x bar out of this part. We could factor x bar out of this part. So really I could divide by x bar. And that will give me 3 minus 2u dx bar minus 2 plus 7u times u dx bar plus x bar du equal to 0. Okay, now what else we got here? Let's go ahead and sort of flesh this out here. I've got the dx bar terms will be 3, I've got minus 2u dx bar. So minus 2u dx bar, here's another minus 2u dx bar. That's minus 4u. And then we have a minus 7u times u is minus 7u squared. Minus 7u squared. And that's the dx bar terms. As far as the du terms, we have minus 2 plus, oops, sorry. 2 plus 7u, this part times x bar, which I'll keep factored out, du equal to 0. Alright, so hopefully that's all correct. I'm kind of glancing at this. I'm thinking this is going to be correct. For one thing, it's a textbook problem. They tend to design textbook problems so that they're doable. And here's my clue here, being practical. If you take this derivative, you get minus 4u, minus 4u minus 14u. That's a multiple of 2 plus 7u. So that tells me that I think we're going to end up with logarithms. So you'll see what happens. If you don't see it, don't worry about it. It'll come to life here. Well, I've got to do more erasing, so I'm going to erase out this part, leave my equation, and then we'll separate the variables.